All right, good morning, everybody. Today, we are going to be talking about percent error. Okay. Now, we've already talked about percent application. We've talked about percent of change and percent of error. So the percent of error is pretty similar to the percent of change. Okay. There's a couple things we need to go over first, okay, before we get started, or before we get into some examples. So we have percent error, and then we have what's called absolute error, okay? Now, the absolute error, we're not talking about percentage when we're talking about absolute error, okay? We're talking about how much we were off. So if we guessed a number, say if we were talking about gumballs, and you had a jar full of gumballs, and you guessed it to be 350, but there were actually 400. Okay, the absolute error is just the amount you were off, not a percentage you were off, just the amount. So we were off by 50, so our absolute value would be 50. Okay, so the absolute error measures the difference between the approximate, okay, that says accepted value, and the exact, okay, or the measured value. Okay, now approximate or accepted we can say estimated. Okay. So the estimated amount, estimated value, and the exact or measured value. Okay. It can be solved by finding the absolute value of the difference between the approximate value A and the exact value V. So the absolute value, if you remember those absolute value bars, so A minus V. Okay. All right, so we're just doing the accepted value or the estimated over the exact value, okay, or subtracting. So let's look at just a couple examples. So a science experiment calls for, this is what it calls for, 150 milliliters of water, but Simon measures out 147 milliliters. What is the absolute value, or what is the absolute error? Well, this is what it calls for. It calls for 150. Okay, he measured out 147. So you see where it says exact, that's what he measured. Okay, so this is what he actually did. Okay, this is exact. So we'll do the absolute value bars. Okay, because we want this, we don't care right now if it's a negative or if it's a positive. We just want to know how far you're off. Okay, so the absolute value, so you take 150 minus 147, well, that gives you 3. Okay, we'll say the absolute value of 3, well, that's still 3. Okay, so the absolute value is 3, and we're talking about milliliters. Okay. All right, let's look at example 2. A student measured the mass of an object to be 56 grams. All right, so what did that student do? They measured it to be that much. Okay, but the actual mass was 53 grams. Okay, so what is the absolute value or absolute error? Well, if he measured 56, well, look, it says the exact or measured value is V. Okay, and the approximate value, okay, is 53. So now we have 53 minus 56, and we do our absolute value. Well, 53 minus 56 is negative 3. Okay, but we're going to do the absolute value. So the absolute error is 3, and it's 3 grams. Okay, now you'll just have a few questions about the absolute error. All right, let's get into the percent error. Okay, the percent error compares the absolute error to the exact value. Okay, so example, when calculating the mass of an object in science, measuring the distance, or a couple examples, when calculating the mass of an object in science, okay, or measuring the distance an object has traveled. Okay, it can be solved using a percent error equation. Okay, and that is very similar to the percent proportion. Okay, so it's we're still kind of in the same area. We're still kind of doing the same thing with cross multiplying and then solving, in which the values are plugged into the formula below. So we'll talk about this one because this is set up the same way. Okay, so your percent over 100, okay, and then we have the approximate minus the exact. Okay, so we said the approximate is basically the estimated. Okay, so the estimated over the actual. Okay, estimated subtract the actual amount, and that's all over what it actually was, so the exact amount. Okay, so the estimated amount subtract the actual, so the difference between the values divided by the actual or the exact. So let's see how this is going to look. During a school assembly, Miss Quinn takes attendance and counts 356 students. Okay, so we know we're going to use this 356. In actuality, there were 376. Okay, so like I said, the actual amount. Okay, so in actuality, that's telling you actually 376. Okay, so when I set up my percent error equation, okay, my percent, well, what have we been using for percent? N, right? Is equal to the difference in the estimated and actual amounts okay, divided by the actual amount. Okay, so now we don't know the percent. Okay, so this is what she counted. Okay, this is what she thought. Okay, this is about, what she thought that she counted. So 356 minus the actual amount. Well, the actual amount is 376. Okay, and we're going to divide that again by the actual amount. Okay, now the difference in these, okay, and this is the absolute value amount. Okay, I'm going to work my way back over here. So 356 minus 376 is going to give you negative 20, but we just want to know the absolute value of it. Okay, so the difference over the actual amount. So we can cross multiply. Okay, so we got 376 n equals to 2,000. Okay, because 100 times 20, n times 376. We're going to divide by 376. Okay, because we want n by itself. So now we have 2,000 divided by 376. Okay, so remember 2,000 is on the top divided by 376. All right, this is your percent. Now, we'll want to round either to the nearest tenth or the nearest hundredth. So right now, we're going to round to the nearest tenth. So there's the decimal point. The tenth is the first decimal. All right, the first place to the right of the decimal. So you look at this one. All right, we're going to round to this one. So we look at the second, the hundredths place. If this is 5 or more, we round this one up. If it's less than 5, this one stays the same. So we have 5.3, and that is 5.3%. So your percent of error is 5.3. Okay? Now, there is another way we can do this. Okay? Once we find the difference, okay, so we'll do the difference over the actual, okay, and that was, we already know that was 20 over 376, okay. Well, anytime I told you that we had the part and the whole, this is kind of what this is saying, the part and the whole, okay, so we'll take 20 divided by 376. All right, this kind of cuts out a couple steps. All right, now I get a decimal, right? And what was I supposed to do with that decimal? If I had the part and the whole, I get that decimal, then I times it by 100. And that gives me my percent again. Okay? And then I'm going to round it, so. All right? So you can do it either this way or you can do it this way. So if you do it this way, you're just going to find the difference in the amounts, divide it by the actual. Okay, that's going to give you a decimal, and then times it by 100. Okay, that's a little bit less math, a little bit less steps than doing the percent error this way. Okay, I'll show you both ways on this next one too. Okay, in a crowded sports arena, 250 seats are counted. Okay. If there is a 20% error on the count, what is the range of acceptable number of seats? Okay, so we're kind of going a little bit different now. This time, we know our percent. Okay, so we need to use the percent error equation. So we need to use n over 100 is equal to the difference, okay, over 250, because that's how many were counted. So that's the exact amount. Okay, that's the actual amount, so 250. Okay. Now, in this case, we know our percent. Okay, so that's 20 over 100. And we'll just use D for the difference. Put my 250 there. So we're just going to solve it like we do our proportion. Okay, so 100 times D, that's 100D, is equal to 20 times 250. That's 5,000. Okay. We will divide each side by 100 because we want to get D by itself. Sorry. We want to get D by itself. Okay. So 5,000 divided by 100, well, that's 50. Okay. So what this tells you is there's a difference of 50. Okay. So when we're asking about the range, okay, well, we could have been, we got 250 seats. Well, if the difference is 50, well, we can add 50 to it, and that would give us 300. Or we could have been, we could have counted more. Okay, so you would subtract 50 from it, and that gives you 200. Okay, so when it asks for the range, you're going to take the difference and you will add it, and then you will subtract it, okay, from the exact amount, from the actual amount. Okay, so your range now is 200 to 300 seats. Okay, so 2 to 300 seats is your range. Because our percent of error could have been, well, we could have been 50 seats off. Okay, we could have been 50 seats. We could have counted 50 seats less than what was there. Okay, or we could have counted 50 seats too many. Okay, so if we counted 50 seats too many, then there was actually 200 seats. So that's your range. So if you have a question and it asks for the range, once you find the difference, you're going to add, and then you will subtract it from your actual amount, and those two numbers are your range, so 200 to 300. Okay? Let me see here. Let's look at one more. I think we got enough time to look at one more. All right, we'll just look at number 2 here, okay? A birthday party host planned for 20 people, but 17 actually attended. What is the percent error, okay? So it tells us that how many actually attended? 17, okay? So I can take my percent error equation. So this is the difference in the two, okay? And this is over the actual amount, okay? So we don't know our percent, so that's going to stay the same. The difference, okay, 20 minus 17, well, that's 3. The actual amount is 17, okay, because it says, but actually, that's how many people actually came. Okay. Now, we can cross multiply. Okay, so I have 17n is equal to 300. All right, I'm going to have to move this up here. 17n is equal to 300. 300, not 100. Sorry. Okay. I'm going to divide each side by 17 because I want to get n by itself. I want to know that percent. So now I have, remember, the numerator, the top number, divided by the bottom number. Okay? So again, we're going to round to the nearest tenth. So this number right here. So I'm going to go 17 point. Well, there's 6. Let's look at that next number. That's a 4. So the 6 stays the same. 17.6% of error. Okay? Now, like I told you a little bit earlier, once you know the difference, you can take the difference over the actual. You divide those, and that will give you a decimal, and you just times that by 100. Okay, that's when you know the difference and the actual amount. Okay. Today's assignment will be short. Okay, just 5 or 6 problems that you need to work on. Okay, and we need to start working on writing them out and working through them instead of just trying to do them on the calculator. We need to start handwriting them out, to practice these, okay? So this will be all for percent of error for right now, okay? And for those of you that I'll see in class, you'll get this in class. For the ones that are not, you need to watch the video and complete the assignment.